Hello, my name is Brandon Sundell. I'm recording this video for Management 3700 Operations Management. Today I'm going to be talking about the theory of constraints, and I'll show a basic overview of that, how it can be applied within the food service industry. The theory of constraints is a management philosophy that is focused on identifying the most serious constraint or bottleneck within a system, and then eliminating that. So this would be our bottleneck. Theory of constraints, the goal of that is to eliminate that, so take our capacity from here back up to here, where our full capacity for our other processes is. So once that first constraint is taken care of, the process is repeated, focused on the next constraint until you just keep improving and improving. When trying to increase capacity of a system, any improvement that is not at this bottleneck is completely useless. If you try to increase here, guess what? You're still limited to your bottleneck. Increasing here won't increase anything until you increase your bottleneck right there. So there are a few different types of constraints a company could face, and these constraints can be divided into three categories. First would be physical, which would be machine capacity, material availability, possibly a space limitation. The next is a market constraint. For example, your demand is too high or low. Either you can't meet the demand, or demand is too low and your resources are being wasted. The third category would be policy. And there's actually three different types of policy constraints that you might face. First one being mindset, measures, or methods. And then Dr. Goldratt, one of the founding fathers of the theory of constraints, actually claims that 99% of constraints a company face are actually policy constraints. So those are often actually overlooked because these constraints are often where people go first when they're looking to improve their systems. Now, let's look at how this theory can be applied to the food service industry. To make this analysis more simple, and also in light of the current COVID-19 situation, we're going to be analyzing the order flow of the restaurant I work at, where we are currently offering takeout only, because this will simplify our analysis. Otherwise it gets really complicated when you're seating people, they leave, as well as takeout. So the basic flow of an order would look like this. Number one, the order is placed. Number two, the order would be sent back to the kitchen. And three, the order is made. 4, the order is assembled by our servers. And then 5, the order is given to the customer. So a basic diagram for that would look something like this. Here's our cashiers who would take the orders, or then get sent back to the kitchen, where we would make the orders. Once the orders are made, they're actually placed in this window here, where our servers then take it from the window, assemble the order, and then bring it back out to our customer. So ideally all these steps would actually have the same capacity and throughput time, then we'd have a perfectly efficient system. However, this is rarely the case in any industry really, especially the food industry. Types of constraints faced by a restaurant could vary pretty much every day, depending on factors such as staffing, who you have there working, are they fast, are they not, or how busy we are, if we're too busy, if we're not busy enough. Those could all affect our ability to get the orders out in the most efficient manner. We can divide our process here into three potential bottleneck locations, and those would be orders taken, orders being made by the kitchen, and orders being assembled and given to customers. So depending on where where our bottleneck is occurring could have a big effect on where the waste in our system is. So let's say we have a really busy night, we're taking a ton of orders. And this is our capacity for orders taken that night, the amount we're putting through. Well, let's say you're putting through more than the kitchen can handle. And so this is the amount of orders being taken. This is the amount of orders actually being made at once, our capacity in the kitchen. And then this is where, this is the amount of orders being assembled and put out all at once. When we have our biggest constraint here on the back end, what happens is it limits our capacity in these other systems all the way down to here, which means all of this extra space in our previous systems is where we're seeing backup orders here, right there, are getting backed up because the kitchen can't handle that many. Orders in the kitchen are getting backed up because our servers can't get them out in time. That's one potential situation for bottlenecks. Another is, let's say it's a really slow night instead of a busy night. We're only receiving this many orders at a time, where the kitchen has the capacity to put out that many, and let's say our servers can put out the same as the kitchen is putting out. Problem with this here is now all of this extra space in these processes is resources being wasted, because we have the potential, we have the staff, we have the ability to make this many all at once, but we only can make this many because that's how many orders are coming back. Now let's say it's a busy night, we have a ton of orders coming back, kitchen is understaffed, we can only make that many orders, but we can, we have some extra servers on hand, they can put out that many orders. Problem here becomes not only the backup of orders here and here, but also the wasting of resources here and here, which is obviously not ideal. So that's a basic overview of the waste that is caused when you have a constraint either on the front end or the back end. If your waste is up here on the back end, you'll be backed up over here. If your waste is on the front end, over here, you're going to be wasting resources on this side. So there's your basic overview of the theory of constraints and its basic application and effects of that it can have within a restaurant.